Hello world, my name is Victor Engelmann. Welcome back to this video series on professional network design. In the last video we've talked about VLANs, so we've grouped our switch ports with these VLAN tags, and that gave us these virtual LANs. And virtual LANs are good for isolating devices from one another. For example, if you want to protect your workstations from attacks of infected printers, for example. But yes, you still need some form of communication between your devices, right? I mean, if you put your printer in one VLAN and your workstation in a different VLAN, right now they cannot communicate with each other at all, so you wouldn't be able to print. Okay, so why have you bought a printer in the first place? And that's what we are doing today. We will now make it possible for the VLANs to communicate with each other. For now, we will allow any communication between the VLANs, which basically just obliterates the security that we've built last time, but in a future video we will get this security back using firewalls between the VLANs. Okay, so for now we will just allow any communication through, just for now. Okay, so what we did last time is we've had this Raspberry Pi, which we had configured to be a switch and have virtual network interfaces that labeled the packets automatically with the corresponding VLAN tags, so that the Raspberry Pi effectively is member in all VLANs right now. Okay, and what we will do now is we will configure this Raspberry Pi to be a router. Now, you probably know the word router from your internet router at home. But yeah, that's just a simple example of a router. So what a router generally does is it connects multiple networks. Okay, and here in that case, over here, you have the big network called the internet on one side and your home network on the other side, and these are the two networks that you connect through that router. But in this case here, we can have our different VLANs. Connected to that router, and then you can configure it so that if a device over here wants to communicate with a device over here, it will send its packets to that router, and that router will then propagate this packet into this network, and then it will reach the destination. So in a way, a router is very similar to a switch, right? A switch did this based on MAC addresses, right? It had this MAC address table. And a router is also called a layer 3 switch, which means it basically does the same thing, except it's not based on MAC addresses, it's based on IP addresses. Okay? So a router will have a so-called routing table. Like in this case here, it would have entries for 10.1.1.0/24 to go over this network interface. So it will send that out into this port. Then it will have an entry that says 10.1.2.0/24. It's not on the table, but 10.1.3.0/24 will go through ETH0.3, and 10.1.4.0/24 will go to ETH0.4. Okay, and yeah, that's kind of like the same thing a switch does, except it doesn't care about MAC addresses. It goes by the IP addresses. And that is actually quite simple, at least when you're using Linux, because this whole routing functionality is something that's already built into the network stack in Linux. It's just turned off by default. So we really only have to turn it on, and then this Raspberry Pi will work as a router. And these entries here are automatically there because these correspond to the configuration of the network interfaces. So we don't even have to set these explicitly. These are already set through the configuration of the different interfaces. Okay, so I have reverted everything back to the state at the end of the last video. So my IP address of the laptop right now is 10.1.4.10 with a 24 net mask here. And right now this network is quite empty. In this VLAN 4 I only have this laptop and the Raspberry Pi, which has a virtual interface in VLAN 4 with the IP address 10.1.4.254. See, up there I can ping that. So let's see. Okay, I can reach this Raspberry Pi. I can log into it with SSH. And now I want to configure this Raspberry to work as a router. And this is not very hard in Linux because the Linux network stack already contains the whole functionality of a router. It's just turned off by default. So all we have to do is turn that on, and then we have a router. Okay, to do that, I will go to etc syscontrol.d and create a file here. Let's call it 20-router.conf. And in here we just have to set two settings: net.ipv4.all.forwarding equals 1, net.ipv6.conf.all.forwarding equals 1. Although I'm only configuring my network here for IPv4 and not IPv6, so I might want to disable this for IPv6. Okay. Okay, I've restarted the network stack. I'm not sure if restarting the network stack is enough to turn this on, because this configuration file is, I think, something that's done on startup and not, maybe not here. So sudo syscontrol net IPv4 conf all forwarding. Yeah, it's still set to 0, so let's overwrite this with 1. Okay. So now the Raspberry should forward IP packets that I'm sending to it. So yeah, the Raspberry should be a router at this point. And yeah, so let's go back to our network settings here. And now I will configure this Raspberry as my gateway or router, or however you want to name it. Okay. Okay, now I will take another Raspberry Pi and put it into the network. This Raspberry Pi is now on VLAN 1. Okay, so outside of my whole VLAN stuff. So let's see. If I'm communicating from the Raspberry, so from my router, then I can ping this new Raspberry there. Okay, I've given it the hostname nettest, and from my laptop I can communicate with the router. And as I said, the router should forward the packets. Okay, so in theory at this point you might expect this to already work, that I could now communicate from the laptop to the nettest. Okay. We are doing this with IPv4, so I will need the IPv4 address. That's 192.168.178.38. And let's try to ping that. And it's not reachable. Okay. Why is that the case? Figuring out problems like this is actually a relatively interesting part of network management, because when you do routing, oftentimes things go wrong in curious ways, but yeah, in this case it's a relatively simple explanation. The point is, let me open another SSH. Okay. And from here, I will now connect to the nettest. Okay, now I'm connected to the nettest in this terminal, the net core in this terminal, and the laptop in this terminal. Okay. The problem at this point is when I'm sending data like an ICMP echo request, also known as a ping, from my laptop, it goes to the net core. The net core forwards it to the nettest. And what happens now is the nettest tries to answer to this ping request, but how does it do that? I mean, it gets a ping request from 10.1.4.10, okay? And it doesn't know how to communicate with that, okay? If it tries to send an answer to 10.1.4.10, it will say, hey, my IP is 192.168.178.38 with a 24 net mask. So it will say, hey, 10.1.4.10 is outside my subnet. So it will send the response to its default router, okay, its default gateway, which is 192.168.178.1, my Fritzbox. And at that point, the Fritzbox doesn't have a root for 10.1.4.10 either, so it might try to send it out into the internet, but yeah, 10. Whatever is a private IP range. My ISP will just delete that packet if it even gets there. I mean, the Fritzbox shouldn't even attempt to send a 10. Something packet out into the internet, but anyhow, this is what happens. The request goes from laptop, netcore, nettest, and the response then goes nettest fritzbox, the end. Okay, and that's why I'm not getting a response. So what can we do now to get a response? Well, one thing we could do is we could add a root directly to the 10. Something range on the nettest. Okay, so let's say, see, I'm on the nettest here. Okay, so everything that's in the 10.1 range I would send to what's the IP of the netcore? Okay, to number 27. Now the netcore gets this IP address from DHCP, so this is really not a good idea at this point to set a dynamic address here. But okay, now with sudo root add network 10.1.0.0.16, or I could be more specific, but if I set it like this, then it would only become able to communicate with VLAN 4, and I want to be able to communicate with all the VLANs through the netcore. So that's why I would set it like this. Okay. Now let's see if okay, I'm not getting a response. Why am I not getting a response? I suspect that the network hasn't taken this gateway setting here. So I will just reconnect it. Yes, you see now I'm getting a response, and in the other direction I can also communicate. But imagine you have a lot of devices. You wouldn't want to set this this additional root on all your devices, right? So you could either put this root into your DHCP server and then tell all your clients, hey, if you want to talk to 10.1. whatever, go through the netcore. That would be one way to do it, but I think that it would be more elegant to use, I mean, I have two routers at this point, right? The netcore and my Fritzbox. And I think the cleanest way to do all this is to give every device a default router through DHCP or whatever, and then have the communication between different networks, between different IP ranges, only through the routers. By that I mean I would want to set the route that I've set manually here, this route. I would set that on the Fritzbox. Okay, so then if the net test responds to the ping request, for example, it will say, hey, I don't have a route for 10.1.4.10, so I'm sending it to my default router, the Fritzbox, okay? And then the Fritzbox should say, hey, I have a route for 10.1.4.10. I am sending it to the net core, okay? So that your routers become kind of the backbone of your whole network, okay? Okay, how can I do that now? Yeah, I think I need to plug myself into VLAN 1. Okay. Okay, so now on the Fritzbox, I'll go to Home Network, Network Settings, and down here I have a setting for static routing tables. Okay, IPv6 routes. So I will put 10.1.0.0 with 255.255.0.0 to 192.168.178.27. Now, the net core should really have a static IP address in that 192.168.178 range, because if it gets a new IP from the DHCP server, then things would go bad. But okay, activate the route and okay, good. Now save. Now I will go back into VLAN 4. Okay. So now I should be able to ping 192.168.178.1. I should be able to ping my Fritzbox, and I'm able to ping my Fritzbox. This is looking very good. Actually, at this point, I think I should even have internet access from my laptop. I don't have a DNS server, I think. So I think that's why I'm not seeing anything here. But I can ping the internet, so 8888 is a DNS server by Google. So if we use that for DNS right now, yes, now I can ping Google and I have internet access. So yeah, this is one of the reasons why I really think that your routers should know all the routes. For example, so that I'm getting responses from the internet which goes through the Fritzbox. So the Fritzbox needs to know a route into my VLANs. Here I want to look into the routing table. With root you get your routing table, but I prefer root-n for numeric, so that it doesn't replace things with these names here. Okay, so what do we see here? The default root 0000 with a 0 net mask, so anything without matching any part of your own IP address can be reached through the Fritzbox 192.168.178.1. Okay, so having anything here with a net mask of 0, yeah, that's your default gateway. Okay, so this is how this is represented inside your routing table. Yeah, this here is 192.168.178.0 with a 24 net mask. Means this is my own subnet without a gateway. This 0000 as gateway means we are talking on link, which means that if I want to talk to devices in this range with this net mask, then I'm doing an ARP request to get a MAC address, and then I'm talking to that MAC address directly. Okay, so that's what this entry here means. And this here is the entry that we created earlier, right? So for 10.1.0016, we are talking to the net core. Okay, good. But yeah, now that the Fritzbox has a route into the VLANs and we have a route to the Fritzbox here, we don't need this route anymore. I mean, we could have it for direct communication without going through the Fritzbox. This is actually a bit of a matter of taste, you know. With this route, things might be a bit faster, but not much faster. And yeah, I think things just work cleaner if they go through the default routes. So it doesn't really make sense to still have this route. So let us delete this route. Okay, good. So now the route is gone. But suppose you want to have that route. I mean, right now we don't need it, but it's also a bit of a matter of taste, and there are other situations where it might make sense to have some static routes, like for example, if you run multiple IP ranges on the same network, then it might make sense to put a static route in there. I mean, that's not considered good style, but it's possible. So yeah, there are reasons why you might want to have a static route, and the way I did it before here with this route add has the problem that when you restart the device, the route is gone. Okay, it's not restored on system startup. So what you need to do is you need to take this command that we had before and put that into a startup script. Okay, here in lib dhcp-cd, dhcp-cd hooks, you can create a new script, for example, like this. Paste the command here. Maybe put a shebang in there. Save, quit. Yeah, this probably needs to have the execute bit. Okay, and yeah, now let's reboot this. Okay, the device has rebooted, and now let's look into the routing table, and yeah, there is our root. So this is how you can make a root permanent. And yeah, this is all I wanted to show you today. If you like this video, like it, share it, subscribe, and see you next time.